The addition of HBr to an alkene is a fundamental alkene reaction you're going to learn in Organic Chemistry 1. And it's important because it introduces the concept of regioselectivity with the Markovnikov addition of the bromine, in that the bromine will add at the most substituted position, which is the Markovnikov product. So why does it do that? We're going to go through a couple examples now and the mechanism first so you can get the hang of it. So the first thing that we do with our mechanism, we need to draw what HBr looks like. And it is a proton bound to a bromine. So now the pi electrons in our pi bond here are going to come and grab that proton. Now remember, we always draw our arrow from our electron source to what we are grabbing, and the double-headed arrow like this means 2 electrons. We will then push these electrons up onto our bromine, which gives us an intermediate that looks like this. Now, because this position is electrodeficient, we have to give it a carbocation, which is why this is called a carbocation intermediate. Oops. Now, this carbocation intermediate forms the most substituted position because the most substituted position is the most stable position for a carbocation. The more substituted the position, the more stable the carbocation. Now, we also have our bromine anion just over here. Okay, this has a negative formal charge. This has a positive formal charge. What can we do here? Well, we can attack that position, and there's an equal chance it comes from behind or to the board, and then we will get our product right here. And that's what gives us the Markovnikov addition of the bromine at the most substituted position, because that is where the carbocation forms to be attacked. Now, what if we have a symmetric molecule like this? Butadiene. Not butadiene, I'm sorry. Butene. 2-butene. Can't talk today. Well, it kind of doesn't matter which one you pick because they are both equally substituted. And so you can draw it like this, or you can draw it like this, because these equal each other. They're the same molecule. Now, when you get into rings, you need to be a little more specific, like a cyclohexane ring. Keeping that in mind, you will need to show the stereochemistry. But for right here, for our purposes right now, the main thing you need to remember is that this gives Markovnikov addition because it goes through a carbocation intermediate. So I hope that was a good example for you. And for more organic chemistry learning, hit that follow button.